Hello there, mathematicians. This is Mrs. Crawford, and we're going to go over Day 5 notes, which is on AAS and ASA, which stands for angle, angle, side, and angle, side, angle. Now, once you know those abbreviations, it's kind of self-explanatory if you've been doing the proofs that we've been tackling the last couple days. Still going to be starting with the given, ending with our proof statement, and then making sure we hit all these pieces that these abbreviations represent. So obviously if I'm solving with AAS, I should have a pair of angles, and a pair of sides in that order. So that's the stuff that we're going to be talking about in this session today. Again, very, very similar to the stuff we've been dealing with before. So a couple things to remember, few definitions. When it says included angle or included side, it means the angle between two sides, or if it's an included side, it's the side between two angles. So included just means between. So make sure you put down those fill in the blanks on your notes. And then we have two sections to fill in for our two different triangle congruences. So ASA goes angle, side, angle, and the side here specifically is in the middle of the two angles. So if two angles and the included, or the side that's between, the included side of one triangle are congruent to two angles, and the included, again, the side that's in the middle, that's between, of another triangle, then the two are congruent. So in other words, if they both go angle, side, angle, then it works. So if we look at our picture, we've got angle B and angle E. So there's our first angle pair. So angle B is congruent to angle E. There's a side marked here with a little tick mark. So there's our side that's in the middle. Same thing here. So that would be BA is congruent to, let's see, ED. So there's our side. And then we've got the double arches for the last angle pair. So angle A is congruent to angle D. If we have all three of those pieces of information, we can say the triangles as a whole. So I'll call it triangle BAC, and then we'll do EDF are congruent to each other. And it would be by ASA in this case. Okay, similarly, AAS has the same pieces, two angles and a side, but this time it's the non-included side. So the one that's not between. And they're congruent to the, and then this would be to the corresponding. So what's kind of funny about this one is you actually have two options when you're picking it. When you do ASA or SAS, you have to pick the one that's in the middle of the two sides or the two angles. But with AAS, you could either have the side after here or after here. So technically you have a little bit of flexibility with this one as long as you go angle, angle, side after. Angle, angle, side after. So in this case, we've got angle A and angle D. A little sloppy handwriting there. We've also got angle B and angle E. And then the side that they picked is this one and this one. But what I was trying to say before is we could have also picked this side and this side if we had valid information for it. We couldn't just obviously say that they're congruent, but it would still go angle, angle, side, angle, angle, side if that was the case. But in this one, they chose the green one. So we've got BC congruent to EF. And then that means the whole triangle BAC is congruent to triangle EDF. And a lot of you guys are doing pretty good with your symbols, but just a quick reminder, make sure you're putting the angle symbol, the congruent symbol, the segment symbols, the triangle symbol, whatever piece you're talking about, you got to put a symbol in front of it. Otherwise, it really doesn't mean anything. So kind of be cautious about that. Make sure you're checking to see that you include that. All right, so let's start tackling these proofs. First one, super easy, should be writing up the given. And you'll notice we've stopped numbering things for you, and we're giving you guys less and less things filled in because kind of gradual release, letting you guys fill in more of the stuff on your own. First of all, make sure you put the given into the picture. The first statement doesn't tell us anything for sure yet, so I'm just going to copy that one for right now. QS bisects PQR. So we'll come back to that. It does explicitly tell us, though, that angle PSQ, so PSQ is this angle, is congruent to angle RSQ. RSQ is right here. So those two angles are congruent. Cool. So I already know one of my angles. I don't know if it's going to be angle, angle, side, or angle, side, angle yet, but I know I've got an angle pair. All right. So that's really all they give us to put in the picture. Now, another thing you need to take a look at is what they tell you in the given. They say bisect. Remember, bisect means to cut in half. So it's telling us that angle PQR, so PQR, this whole big thing here, is being cut in half by QS. Well, what does it mean if you have two halves of a whole? Well, if they're equal halves, they should be equal to each other if they're actually half. That means that this angle got split in half. One of the halves is right here. So that would be angle PQS. And the other one is on the other side over here. Again, this is kind of the piece that's splitting it right down the middle. And then you get your two halves. So RQS is the other one. And kind of similarly to what we were doing before, it's congruent because of the definition of bisect. Literally that word and what it means forces those to be equal to each other, if that's the case. So we have to say definition of bisect. Okay. All right, so we've got two sets of angles now. Got the red one, got the green one, because one of them was already given. We figured out that it's bisecting, so that's awesome. So we've got two of our sets of angles. Now we got to figure out some sides. Well, hopefully you've started catching those really obvious sides. What side here is overlapping? It's the same in both triangles. It's this one right here. So number 3, we have QS is congruent to QS. And notice I'm still numbering on each side, and hopefully in your brain you were thinking reflexive. That is going to be something you see on the quiz a lot, so be ready to recognize that and use it. So now I've got angles here, side in the middle, angle on the outside. That's enough to do which one of these? Is it AAS or ASA? Is the side in the middle, or is it after the angles? It's in the middle, therefore we're using this one. So actually we didn't need this fourth box. Just threw it in there to see if you guys were paying attention. So triangle PQS is congruent to triangle RQS. And the reason, like we just said, is ASA. Alright, make sure you get that copied, and then we'll move on to the next one. Alright, so this guy is going to take a little bit more work. We've got some parallel lines going on here, which is going to be a little bit tricky, but we can handle this. Let's start by just writing out the given. Notice this time we didn't include any boxes to tell you how many steps you should have. So again, kind of letting go of helping you guys. Oops, that's supposed to be bars. ST. And this is given. Now the first one's pretty easy. RQ is congruent to ST. We know what that means, and it's actually already marked it for us right here and right here. If you forgot what this means, you need to write that down because you have to know that that means parallel. Now, if you see the phrase parallel, you should start looking for either alternate interior angles, corresponding angles, alternate exterior angles, and really we don't need to be looking for vertical angles necessarily, but I'll throw them in there. They don't have to have parallel lines though. But these three are the ones that do use parallel lines and they're congruent to each other. So it's kind of important that you be able to recognize those, even though it's from a unit that we aren't necessarily focusing on anymore. So I'm going to draw my parallel lines here, like this. Okay. And so now I need to figure out what are some things in the two triangles. Oops, that's not what I wanted. That match. Now let's see if I can do this. Okay. So what I'm going to do is actually twist this way. And you can do it by just turning your paper. That would probably be the easiest way to get that. So let's make use of these parallel lines. So remember, when we did it, we kind of had a shape that looked like that. That was our transversal shape. If we wanted alternate interior, they have to be between the two lines on opposite sides. If they're corresponding, it's one outside, one inside, and they're in matching spots. And then alternate exterior, they're both on the outside on opposite sides. Now, if we're looking at our picture, we can just pick one of the lines that cuts through. So I'm going to use T, what is that? P right there? Or no, R. T to R. I'm going to bold that guy in, because that's going to help me pick out some of my angles. And it looks pretty close to my picture down here, actually. This is the line that cuts through. These are my parallel lines. So if I'm looking at this, I can't pick anything out here because there's no triangle out there. That's not going to help me. But right here, I've got an angle here. That's part of the triangle. Down here, it also does this kind of Z shape. And we hit this angle over here. Now notice there's no red line over here. There's no red line over here, so I can't use those. But what type of angles are these? If I look in my picture here, it would look like this and this. If you haven't caught it already, those are alternate interior angles. They're both between the parallel lines. One's on the left, one's on the right. So in our picture, we're going to be able to use that as well. And let me see if I can erase some of that. There we go. So let's twist it back and then we'll simplify it a little bit. So we had parallel, parallel, line cutting through, boom, boom. Okay, so those are our alternate interior angles that we were just looking at before I rotated it. So I'm going to use three letters. I'm going to call this one Q, R, T. You could call it QRU, it doesn't matter. And that's congruent to STR or STU, it doesn't matter. And it's because they are alternate interior angles. So if I'm looking at my angle, side, angle, or AAS, I've now checked off a side and I've checked off an angle. So both of those are workable. Either way, though, I have to find another pair of angles in here. Now, you could do one of two things. I think the easiest way is to use vertical angles. Hopefully you visually might have caught that in the picture. It's one of those bow tie looking pictures or kissing angles. Right in the middle, these are automatically vertical angles. I don't even need to know that they're parallel lines to make that happen. So I could just state that angle RUQ is congruent to angle, RUQ is congruent to TUS. And it would be by vertical angles. Okay, the other way you could do it, so we'll say A here and B here. You could have also realized that you actually have another set of alternate interior angles. If you go this way, we could have also used this guy and done the same reasoning as up here. So we could have also said angle RQS is congruent to angle TSU, and again by alternate interior. Depending on the way you do it is going to change which one of these you use. So figure that out for yours, whichever one you would prefer to use. write your last step, and pick the abbreviation that goes with it.